Okay, polyatomic ions. So up to this point in chapter 6, all of the ions in the examples have been monatomic, meaning they are made up of only one type of atom: chloride, bromide, fluoride, iron 2, copper 1, aluminum, barium, sodium, okay? All of the ones you've seen up to this point have been monatomic ions, made up of only one type. Well, now we introduce polyatomic ions, and the prefix poly, ions made of more than one type of atom. Okay, just like in mono meaning one, poly meaning many. Now, some examples of common polyatomic ions I have listed here. But the yellow ion chart is a very comprehensive chart, and I put this up here. Okay, it's more comprehensive than the tables in your textbook. Okay, so the one I've given you is a good resource if you take chemistry beyond Chem 110. You can see we have many polyatomic ions that are anions. There's only two that are cations. That would be the ammonium ion and the hydronium ion. But all the rest of the polyatomic ions are anions. All right, and I listed here a few of the common ones: sulfate, sulfite, nitrate, nitrite, carbonate, acetate, phosphate, and hydroxide. I put this one up here on purpose because a lot of times people don't recognize hydroxide as polyatomic. It's made up of oxygen and hydrogen. It's only one oxygen and only one hydrogen, but it's the definition of polyatomic, more than one type of atom. It's made of two different types. A lot of your polyatomic ions contain oxygen. They're what we also call those oxyanions. All of these would be considered oxyanions. But some of your other polyatomic ions I didn't list here on the board, but they are included in the yellow ion chart. This is the ammonium ion, which obviously does not contain oxygen. But this is a polyatomic ion as well. Nitrogen with 4 hydrogens. Polyatomic ions, you have overall covalent bonding, which we will be talking about pretty shortly. You have covalent bonding, sharing of electrons between the atoms. And that overall structure has an ionic charge affiliated with it. Whether it's -2, -1, okay, -3, +1, okay. So what are we going to do with the polyatomic ions? Well, we are going to incorporate polyatomic ions into naming ionic compounds and writing formulas for ionic compounds. So it's a good idea to have the yellow ion chart handy, or the chart in the textbook, table 6.7. Table 6.5 has the transition metals with more than one charge, but 6.5 has the 6.7 has the polyatomic ions. So let's keep that chart out. Okay, I would prefer the yellow ion chart, just because you don't have to flip through pages. Okay, it's very comprehensive. That's why I put it up. All right, let's do some examples with formula writing and naming ionic compounds that contain polyatomic ions. To name compounds containing polyatomic ions, we will follow the same rule as we did for compounds that did not contain polyatomic ions. Cation name always goes first, followed by the anion name second. Now, there's one little thing to add with the polyatomic ions when we write the formulas. The polyatomic ion is like a unit. It doesn't get split apart. Sulfate contains 1 sulfur and 4 oxygens. That's an entity. So when we write formulas, we need to keep that in mind. We follow the same rules that were presented in section 6.2 with the value of the opposite ion's charge becoming the subscript of the other ion. But now we need to use parentheses around the polyatomic ion when the charge value that comes from the other ion is not 1 or reduced to 1. Let's see what we mean here with multiple examples. Calcium bonding with carbonate. They both have a value of 2. So the formula would just be CaCO3. No parentheses needed here because these twos go away. The name of this is calcium carbonate. Active ingredient in antacids, calcium carbonate. Does it show? No, it gets blurry. I try to bring it in closer and it gets blurry. All right. No parentheses needed here. But now let's watch. Calcium nitrate. I just gave you the name of it. Oops. The 2 from the calcium will become a subscript to the entire nitrate ion. The 1 from the nitrate, subscript to calcium. So the formula would be Ca, get a better marker here. You may have already written it down or guessed it on your own. Parentheses, NO3, 2. That 2 from the calcium comes as a subscript to the entire nitrate ion. Okay? You do not change the existing subscripts that are part of the polyatomic ion. That identifies that polyatomic ion. Calcium nitrate. Okay. All right. Let's do some more. Let's do some more with polyatomic ions. I'll give a minute for the, if you want to pause the screen for any reason or write something down or make a note. All right. Let's do some more. All right, let's do some more where we write formulas and name the following ionic compounds. Okay, I have some mixed in here where we may have monatomic ions, where we may have monatomic ions that have variable ionic charge, such as some of the metals. Okay, and we have polyatomic ions. Remember, parentheses needed when the subscript that comes from the charge of the other ion is anything other than 1. Let's see by example, as that will help to emphasize the rules here. Okay, get my multiple colored expo markers here. Make sure the board's lined up. Okay. All right, the 1 from the ammonium ion will come as the subscript to the sulfide ion. The 2 from the sulfide ion becomes a subscript to the ammonium ion. Parentheses are needed around the ammonium ion. If you neglected to put the parentheses, it would be completely incorrect to say that you have 1 nitrogen, 42 hydrogens, and 1 sulfur. There's no way that you make 42 hydrogens out of that ionic bond. So the parentheses are important to show what is going on with this compound. This is ammonium sulfide. All right, let's look at the next one. We have +1 and -1. No parentheses would be needed. Yes, we have 2 polyatomic ions, but because the subscripts coming from the other ions are 1, you do not need the parentheses in the overall formula. NH4, NO3, ammonium nitrate. Some of these I happen to have ammonium nitrate crystals. A lot of ionic compounds are, they're crystalline. That's one of their properties, crystallines or powders. They come in different colors, except the ones I have in my possession are pretty much white solids. If I was on campus in the lab, you would see ones of various colors, but I don't have them in my home. So this is ammonium nitrate, which comes from cold packs, instant cold packs. If you ever had a swelling or a bruise, and you have those instant cold packs, which you smack open and they get cold instantly. The crystals in there are ammonium nitrate crystals. All right, let's get back to what we're doing here. Okay, so now we have the next one. The 2 from the barium comes over as the subscript to the hydroxide. The one from the hydroxide comes over as a subscript to barium. Remember, we don't write subscripts of 1. It's understood that we have 1 by the symbol alone. Okay? But hydroxide is polyatomic. Don't be fooled that it's not, because you don't have a little subscript with it. It's made up of 1 oxygen and 1 hydrogen. Thiocyanate is another one that's polyatomic that doesn't have any subscripts. Cyanide is polyatomic, 1 carbon, 1 nitrogen. So there are ions that are polyatomic, more than 1 ion, but they don't have the little subscripts here because that's not what they're made of. Barium hydroxide would be the name of this ionic compound. Okay. Let's keep going. And if at any point you want to stop in the video and try it on your own, and then see me go along with it, you can do that too. Formula will be Cu3 parentheses PO4 2. Now we need to name this. Copper is one of those ions that could have more than 1 charge. So we look at our ion chart to assist us, or we could just look right at the ion right there, copper 2. Or you could just look here, that 2 came from here, copper 2 phosphate. Okay. Next one. Okay. Formula will be Fe2 So4 3. Iron is one of those ions that has more than 1 possible charge. Iron 3 sulfate. Sulfate and sulfide are different. Okay? An ion chart, you have it. If you get mixed up, you can refer to it. This ion and this ion are different. Okay, so spelling matters. I'll have students sometimes say in an in-person class, does it matter if I spell it wrong? Yeah, because it's a different ion. It forms a different compound. Okay, so we have the ion chart to help us to write that correctly as a reference. All right. Now the next one is actually the active ingredient in bleach. Let's write the formula. NaClO. No parentheses needed around this ion, this polyatomic ion right here, which is made from 1 chlorine and 1 oxygen. No parentheses needed because the charge coming from the sodium is a 1. The name of the compound would be sodium hypochlorite, which is the main ingredient in bleach. It's the active ingredient in bleach, sodium hypochlorite. It's also used in a higher concentration for municipal water purification as well. In the textbook, throughout chapter 6, they give pictures and examples on the side of different ionic compounds. At a lab that I had developed also, I tried to incorporate that in there as well. You have so many items in your home that are made with ionic compounds. Toothpaste, okay, has an active ingredient of sodium fluoride. Now, if you use sensitive toothpaste, the active ingredient may be a tin fluoride or a potassium nitrate, but you have ionic compounds in toothpaste. So go look at your toothpaste and check out what the active ingredient is, okay? I'm sure that every person watching this video has toothpaste in your house. If not, go out and get a tube, okay? Keep your teeth nice and clean. Okay, I already showed the antacid bottle, okay? Whether you buy generic brand, name brand, active ingredient is calcium carbonate. It's in different concentrations if it's extra strength or maximum strength or regular strength. Automatic dish detergent. sodium silicate, along with sodium carbonate. Regular table salt. I already showed you the ammonium nitrate from the cold pack. Rock salt, calcium chloride, okay, the bigger crystals there. Baking soda, sodium bicarbonate, okay. I only have the white powders at home, but copper compounds usually are blue or green solids. Nickel compounds are usually orange. Cadmium compounds are usually yellow. Your transition metals give you cool looking colors. Iron can be anywhere from orange to red. Sometimes it even gets purple. So it gets the compounds that make up with it. Epsom salt. If you have Epsom salt in your home, that's an ionic compound, magnesium sulfate, but it's also a hydrate. It has so many molecules of water that are part of it. But anyway, so I'll conclude this section with that. Take a look around your house and see what kind of ionic compounds you have. Okay, not everything is an ionic compound, but I just listed some for you, so you can check that out. The next section, section 6.5, talks about introduction to molecular compounds and naming those types of compounds, which is different naming system than ionic compounds. So that's our next video.